Hello, space fans, and welcome to another edition of Space Fan News. In this episode, astronomers observe a star that has gone supernova, not once, but twice. And the Giant Magellan Telescope starts casting its fifth mirror segment, and ALMA provides us with the most detailed image of a red giant star ever produced and gives us a glimpse of the fate of our own solar system. Most space fans have learned by now, as most of us have been taught, that when a very massive star dies, they usually explode in a fiery event known as a supernova. And these cataclysmic deaths usually result in a beautiful, expanding cloud of stellar debris that leaves behind a remnant, a rapidly spinning neutron star called a pulsar, or a black hole. And, well, as supernovas go, that's usually it. Now, while this event is spectacular and amazing, it usually only happens once. I mean, how many times can a star die, right? Well, as with most things about the universe, things aren't quite that simple. Astronomers using the Keck Observatory on Mauna Kea in Hawaii have found evidence of a star that has gone supernova at least twice over the course of the last 50 years. The team was quite surprised that after having discovered some 5,000 supernovae, they had never seen one quite like this. The spectra from this event looked like a normal, hydrogen-rich core collapse supernova, which lasts about 100 days. But the spectra from this one grew brighter and dimmer at least 5 times more slowly, stretching out an event which normally lasts 100 days to over 2 years. The supernova, named IPTF14HLS, was discovered in September of 2014 by the Palomar Transient Factory. I love that name. And at the time, it looked like an ordinary supernova. But several months later, Las Cumbres Observatory astronomers noticed the supernova was growing brighter again after it had faded. When astronomers went back and looked at archival data, they were surprised to find evidence of an explosion in 1954 at the same location. This star somehow survived that explosion and exploded again in 2014. Now, the star that blew up was at least 50 times more massive than the Sun and probably much larger. Supernova IPTF14HLS may have been the most massive stellar explosion ever seen. The size of this explosion could be the reason that our conventional understanding of the deaths of stars failed to explain this event. We just haven't seen one quite this big yet. So, to try and understand this strange observation, astronomers did what scientists often do when they see a new thing. They make up a new category of thing and put whatever it is in there. Now, what this might be, astronomers say, is something called a pulsational pair instability supernova. And if you don't know what that is, don't feel bad, you're not alone. I'm learning all about this myself. Apparently, according to this theory, what may have happened is that this was the result of a star so massive and hot that it generated antimatter in its core. And that would cause the star to go violently unstable and undergo repeated bright eruptions over periods of years. And that process may be repeated over decades before the star's large final explosion and it finally collapses into a black hole. The main problem, though, is that these pulsational pair instability supernova are only supposed to really occur in the early universe, when the universe was less than about 1 billion years old. This supernova is much closer to us than that, only about 500 million light years away, so it's basically happening today in cosmological timescales. Another problem is that this supernova was more powerful than what most pulsational pair instability supernovae are supposed to be. So this theory doesn't fully explain the observations. So astronomers basically really don't know what's going on here, and they'd love to see another one. And they're going to keep watching this one, though, because, well, that's all there is. And they also can. It stays bright for 3 years after it's discovered, so it's still bright right now. So there you go, folks. Just when you think you understand something like the deaths of massive stars, you see something you've never seen before that doesn't fit into our knowledge of how we think the universe works. So science is a never-ending journey. It's always something. Next, The Giant Magellan Telescope Organization, or the GMTO, announced that it has started the casting of the fifth of 7 mirrors that will form the heart of the Giant Magellan Telescope, or GMT. When completed, the GMT will be the largest telescope ever built. The 25-meter GMT will be built in the Chilean Andes and will be used to study planets around other stars and look back to the time when the first galaxies formed, which actually kind of sounds a lot like what the JWST will do, only it's going to do it from the ground. Okay, now listen to this because it's incredible. The process of casting the giant mirror involves melting nearly 20 tons of glass in a spinning furnace. This spinning will give the mirror its initial shape, and once it's cooled, the glass disc will be polished to its final shape using state-of-the-art technology developed by the University of Arizona. The GMT will combine the light from 7 of these 8.4-meter mirrors, that's each, to create a telescope with an effective aperture of 24.5 meters in diameter, which is about 80 feet. And with this unique design, the GMT will produce images that are 10 times sharper than those from the Hubble Space Telescope, especially in the infrared region of the spectrum. Now, this really is a different way to make a mirror. I've never seen anything like this. The mirrors begin as these pristine blocks of custom manufactured low expansion E6 glass from the Ohara Corporation of Japan. Precisely 17,481 kilograms of these glass blocks have been placed by hand into a custom-built furnace preloaded with a hexagonal mold. At the peak of the lengthy casting process, in which the giant furnace spins at up to 5 revolutions per minute, the glass is heated to 1165 degrees C, which is about 2100 degrees Fahrenheit, for about 4 hours until it liquefies and it flows into the mold. Now, the casting process continues as the glass is carefully cooled for 3 months while the furnace spins at a slower rate. The glass then undergoes an extended period of shaping and polishing, and the result of this high-precision process is a mirror that is polished to an accuracy of 1/20th of a wavelength of light, or less than 1/1000th of the width of a human hair. Now that is how you make a mirror. With this casting, the fifth GMT mirror joins the additional GMT mirrors at various stages of production in the Mirror Lab. Polishing of Mirror 2's front surface is well underway. Coarse grinding will begin on the front of the third mirror shortly, and mirror number 4, which is the central mirror, will be ready for coarse grinding following mirror 3. Now, the first GMT mirror was completed several years ago and was moved to a storage location in Tucson this September, awaiting for the next stage of its journey to Chile. The glass for mirror 6 has been delivered to Tucson, and mirror 7's glass is on order from the Ohara factory in Japan. This telescope, when finished, will be among the largest privately funded scientific projects ever, and continues a trend that we're seeing with a lot of these initiatives, like the Planets Foundation, which you've heard me work with before, and I've worked with those guys, and they hope to build even larger ground-based scopes to find life in the universe. Finally, the Atacama Large Millimeter Submillimeter Array, or ALMA, has made the sharpest observations yet of a star with the same starting mass as the Sun. The new images show for the first time details of the surface of the red giant W Hydrae, 320 light-years distant in the constellation of Hydra. Now, what's important here is that this star is very similar to our own Sun, and it provides a glimpse of what will happen to us in about 5 billion years. Stars like the Sun evolve over timescales of many billions of years, and when they reach old age, they puff up and become bigger, cooler, and more prone to lose mass in the form of stellar winds. Now, as you know, stars manufacture important elements like carbon and nitrogen and all the other building blocks of life, and when they reach the red giant stage, these elements are released into space, ready to be used in subsequent generations of new stars. ALMA's images provide the clearest view yet of the surface of a red giant with a similar mass to the Sun. Earlier sharp images have shown details on much more massive red supergiant stars like Betelgeuse and Antares, but this is the first one of a star like ours. Now, these observations have also contained some surprises. There was the presence of an unexpectedly compact and bright spot that astronomers think provides evidence that the star has a surprisingly hot gas in a layer just above the star's surface, which is called the chromosphere. And, and measurements of the bright spots suggest there are powerful shock waves in the star's atmosphere that reach higher temperatures than are predicted by current theoretical models for AGB stars. Or, and this is interesting as well, this star could have been undergoing a giant flare when the observations were made. So while there is much these observations can teach us about what will happen to a star like our Sun, here's the part that I found the most interesting. This graphic shows the orbit of the Earth, and that's that dotted line there, that is superimposed on the ALMA image of the star. And astronomers, now, in the past, astronomers have never been sure just how large our Sun will get when it expands into a red giant. Some have said it will go out past Jupiter. But this suggests that our Sun may expand out past Mars, certainly past Earth, and stop before it gets to Jupiter. So no matter what happens, Earth is in for a really bad day some 5 billion years from now. Well, that is it for this episode, space fans. Thanks to the Great Courses Plus, which has sponsored Deep Astronomy this month. And please go to the link below and get a free month trial subscription, because they have lectures on all kinds of subjects in astronomy and science that I know you'll love. I'm currently watching a really great one called The Science Wars: What Scientists Know and How They Know It. I'm really getting a lot out of it, so I encourage you to check them out. There's like 3,000 lectures there. And we also survive thanks to Patreon patrons whose contributions each month keep SFN alive. So thank you all so much. And thanks to all of you for watching. And as always, keep looking up. Deep Astronomy is sponsored by the Great Courses Plus, a subscription on-demand video learning service where space fans can enjoy lectures in astronomy from top professors from around the world. I particularly recommend Exoplanets: What Astronomers Know by Dr. Joshua Wynn. Go to thegreatcoursesplus.com/deepastronomy to get a free 1-month trial to check out all the great stuff they have. And you can support Deep Astronomy by getting a subscription. I think space fans everywhere will get a lot out of their courses.